Hi everyone, my name is Satish Kale. I'm a principal specialist solution architect with Red Hat. Been in Red Hat since December 2007. It's almost a decade. I primarily work as a solution architect for middleware and platform as a service technologies. And today's session is about microservices revolving around Paas, which is OpenShift platform as a service, DevOps, and some things beyond that. Now, why now talking about the businesses, okay, some of the very successful businesses like Amazon, Square, Netflix, Uber, they have really disrupted the business. And they were able to do that on the backbone of technology. So whatever software or infrastructure they have used, that has really helped them become really successful at what they are doing. Now, how did they do that? Okay, the primary key word over here is modernization or evolution, whatever you call it. Now, if you look at the four primary pillars, okay, right from your development processes to application architecture, how you deploy and package them, or on what kind of infrastructure, application infrastructure you're hosting on. So if you look all of that and you look at the timelines, people have evolved from waterfall to more agile to using DevOps or application architecture moving from being monolithic to multi-tier to going to microservices, which is a new trend. And of course, the development packaging has moved from physical to virtual servers and now to containers. And application infrastructure moving from data center to hosted, private cloud, or public cloud. Now, what's the key theme of today's discussion is around microservices, but it cannot go without talking all of these four areas. Now, before we go into microservices, I really wanted to introduce very quickly the platform as a service technology by Red Hat. So purely from the usage point of view and the business value point of view, what business expects from infrastructure and everyone else is that when they have an idea, that particular product, new product, or a product feature or addition to existing things should happen really quickly. That means the go-to-market should be really quick. You should be able to do your QA, dev, QA, UAT, and production very quickly with continuous delivery. You should have a very efficient coordination and collaboration between various stakeholders like product manager, developers, engineering, QA team, and the operations. And of course, you should have all those infrastructure, efficient usage of infrastructure by using as necessary infrastructure resources, but also have ability to scale up and down as and when needed. So all of these are key themes when we talk about platform as a service. These are the requirements, expectations from platform as a service. And that's where OpenShift Container Platform by Red Hat, okay, provides you all those features. But before we go into that, let's really have a brief overview about what OpenShift comprises of. So if you look at OpenShift, it runs on top of any particular either physical or any infrastructure, whether it could be physical or whether it could be a virtual, running on top of a Red Hat Enterprise Linux. And then it includes technologies like Docker and Kubernetes to provide you with the container runtime, to provide you a packaging format, support for packaging format, and also provide you container orchestration. But on top of it, Red Hat provides a lot of OpenShift specific things like software defined network. You are able to create your own service catalogs. You should be able to do your own self-service, and that's where on top of that you will run your containers. Now, how do you start? You start by selecting your infrastructure, whether it could be physical, virtual, private, or public cloud. Now, before we go into our layers on top, let's talk about the cloud options. Okay, let's talk about the one of the pillars of modernization, which is moving towards the cloud. Now, with Paas, you should be able to choose your own infrastructure as a service, whether it's, as I said, a physical or a virtual machine, or any public cloud providers like Google, Windows, or Amazon Web Services. Or you could have your own OpenStack cloud solution running on there. So once we have that, what we provide for your Paas to run is basically a node. A node is a machine, virtual machine, or whatever physical machine it is. It's basically running RHEL or atomic RHEL for us, and that's where your containers will run on. Now, before we go into what containers are, and it's basically a very scaled down version of your or partitioned operating system over here, and these particular partitioned operating systems will run, okay, as we call Docker containers. and your applications will run inside these Docker containers. Now, what you achieve by this is that you are sharing some of the core kernel within a node between all these individual container instances, but you are achieving very high scale because now you are able to run a lot of containers. Now, with virtualization technology, you may not get that scale which you'll get in containers. Now, talking about containers, let's focus on that particular part now that we have reached there. What are containers? It's basically a software packaging concept. That means you have a very scaled down version of your resources that you need to run your full system. That means some things which will represent your hardware, BIOS, and OS related things. Okay, so in virtualization, what happens is that you have a host OS, you are a hypervisor, and this hypervisor provisions the underlying compute capacity across virtual guest OSs. But these guest OSs are full-fledged operating systems on their own, and then they have their own individual bins and libraries, and then application runs on these individual virtual machines. Whereas with containerization, you have your host OS, shared services, everything running individually, and from a container point of view, only those non-common bins and libraries are available for your container to run. What this basically means that your density on your infrastructure increases manifold because there's no overhead of having individual guest OSs on top of it, and that's where number of containers that can be run is very high. As you can see, if you're running 10 virtual machines, you could possibly run hundreds of containers over there. Now, what does a container really comprise of? Container comprises of a Docker image which manifests itself into a container runtime and which is embedded into something called a pod. So for OpenShift or Red Hat's Paas technology, pod is the smallest deployable or runtime unit, but under the hoods, okay, pod may contain one or multiple containers. By and large, many a times it contains one container, but there are possibilities where there are multiple containers which are closely related. They can be packed into a single pod. Information about all these Docker images and all those things is stored into something called as registry. Now, how does an OpenShift truly look like? So if you look at these individual nodes, they have multiple pods which contains containers, and that's where your technology and applications are running. But then these are nodes. This is where actual things are running. Then there are master instances. Now, master instances on behalf of the OpenShift or on behalf of its users, whether it's a developer or operation, perform some of the things like providing API and authentication for these nodes, providing a certain persistent layer for data store. It provides scheduling capabilities. That means any new container has to be instantiated on a particular node. All those things will be taken care by scheduler. Management replication to manage high availability. If one of the container instance goes down, then it should be um, regenerated somewhere else. Those kind of things, okay, to manage high availability, that all taken care of. Now, all of these things, okay, whether it's master node, they will run on top of your infrastructure, which is a physical, virtual, or whatever you provide, as long as you provide them RHEL instances. Now, coordination between these containers or relationship between these can be defined by something called a service. So, service is a representation of this particular container. So, if you have a MySQL thing running, or you have an app server running, these are all services. Now, if you want to expose one of these services externally, then what you do is you create a route, and this is what that's where software defined network kicks in and provides an ability to externalize these services outside to make it accessible outside. It has all the configuration of DNS and all those things, and that's the reason you are able to pick and choose what services you are exposing through a routing layer. As I said, persistent storage, you can uh, provide choice of what persistent storage you are giving, and that's decoupled from how it has been used over there. So software defined storage, that's a very key over here. Now, who will be interacting with OpenShift as a layer? Developers, they will be pushing code, they will be deploying stuff from one environment to another. Operations would be doing your CI/CD operations. All of these will be managed and routed through master. Now, benefits for developers and testers for this one is that you get broad selection of application components. One thing I did not mention earlier is that from OpenShift, you not only get Java workloads, but you get a lot of heterogeneous, different kind of polyglot technologies available to you, Node.js or Ruby, all of these technologies will be available for you to develop your applications and run it on containers. Then you have your benefits for your overall different players. Whether it's a tester, they get their own environments. You will be able to push your builds from dev to QA and from QA to production. You have a very seamless and a very developer friendly and IT friendly CI/CD pipeline being created. Now, benefits for IT operations is that you're obviously able to have very efficient use of infrastructure, but you are able to guarantee the availability for all the runtimes now, because OpenShift takes care of containers running, scaling up and down, and if any particular container or node goes down, okay, the container instances can be started on another existing nodes. So all of these hassle of maintaining high availability, of ensuring things are running as per desired manner and SLAs will be taken care by OpenShift. You will be able to effectively partition things so that only authorized users and teams can access and integrate with certain systems. You are able to also control what kind of services you can externalize and what are the services you purely want to be consumed internally. All of these are really great benefits which are provided out of box by Paas or a technology like OpenShift. Now that we have knocked off that particular pillar about containers, let's talk about microservices, which is a modern architectural concept. So what are microservices? It's okay, if you look at the definition provided by Martin Fowler, it's an approach of developing a single application as suite of small services. And each of these service will be running its own process. It will be doing its own communication with lightweight mechanism, and more often than not, it will be using HTTP resource API. So what does this basically means that you are now taking a big application and cutting it down into smaller manageable pieces which are more decoupled, which are very easy to develop and maintain, understand individually. They are self-contained, autonomous, they are decentralized, and individual teams can work individually on these particular services. If they fail faster, innovate faster, iterate faster, and do things much more faster. These are all tremendous benefits when you go with microservices route. But microservices technology come with its own expectation, and we'll come to that. But what benefit it's primarily provide is agility, efficiency, resilience, and revenue. Why? Because now you are able to do things faster. You are able to develop it much more faster and change them things most faster. Efficiency, because you can result in more efficient use of code and underlying infrastructure. Resiliency, as I said, okay, because they won't be having a single point of failure. It of course depends on how you architect them, but you can now have a downtime on a particular service which will not affect any other services, and you can ensure that your downtime is limited to very small section and not affecting the entire application availability. Now with all of these, you get faster iterations, lower downtime, and of course more revenue, because now you are able to push in more things and do things much more faster in much more agile manner, and have a lot of flexibility, so you are able to do, and this all manifests into better revenue for you. Let's talk about a microservices runtime. So microservice and container go hand in hand. As I said, there are expectations from microservices, and those expectations are very well provided by container, and we'll go into how they work together. So microservices require smaller footprint, smaller lightweight environment. They require independence. They need to be decoupled, and all of these are provided by containers. Now look at this example. You have multiple microservices running on their own individual containers. They're running on either RHEL Atomic Host or Red Hat Enterprise Linux, which is basically powering OpenShift Container Platform. Now, if you have certain specific kind requirements, like you want to compose some of the microservices together, you might be using something like Fuse. If you want to just run Java workloads on some of your microservices, which are based on microservices, then you can use EAP. If you want to achieve messaging within your microservices, you can use technology like JBoss AMQ. Or you want to do in-memory caching, you might use JBoss Data Grid. So what we're saying here is that Red Hat middleware portfolio is entirely compatible on this OpenShift Container Platform. Now let's talk about the characteristics of microservice architecture. Independence, survivable, discoverable, okay, which means that they run independently. Even if other services are not available, they are able to survive. They are discoverable. You can look them up. Okay, you know which service they are being mapped to. You can look up and connect to them by that particular service name. They have their own CI/CD workflow. You have a choice to define them like their own life cycle. Again, all of this gives you tremendous, should be able to give you tremendous application density. And how do we support it? By, of course, OpenShift technology. Now, talking about independence, they are built independently. Decoupling is the keyword over here. They can have their own individual representation of data. They can be tested independently. They can be deployed independently, and there could be specific independent teams that could handle that. Now, I'll take an example. Like I have a RHEL as an operating system. I have a Fuse Camel, technology running over there, and I have my code running on top of it. All of this runs on OpenShift. So this is an immutable thing that I've developed. It started with the Docker as a packaging format. This is an immutable. Once I've built it, it remains as it is, which is a great benefit for me because now I can push it across multiple CI/CD. But as an ownership, it lies with me. If I change code, it changes only that particular service, microservice, and on that particular containers that it is running. Deployment, I deploy them as per my needs are there. And I can add my own virtual databases there using technologies like data virtualization or something, or I can have in-memory caching using data grid, and that way that particular container and that particular service has its own representation of data. Now, survivable, you can scale, kill, and survive. That means if particular version upgrade happens, you can just get rid of the older container representation and go to a newer container representation. It also helps you in terms of high availability. If one of the node goes down, the another node can come up easily. All those algorithms for scheduling, when it should be there, whether it should be on the same node or it should definitely not be on the same node to ensure good high availability. So all of these can be configured. So as I said, if a service dies, the platform will take care that that particular service or is running on some other container instance on some other pod. Discoverable, you really don't care where they are deployed. It will be running on many of the 1,000 nodes that are running over there. But as an application who invokes that particular service, or a service calling another service, we need to know where they are. And that's where the discoverability factor comes in. So if you have a service definitions over there, I can invoke them through that particular service definition. So that is where the service layer comes in. Now, what if there are clients which are external of OpenShift, they want to access them, and that's where the routing comes in. So the route, as I said earlier, routes are the addresses, which is like your host name and port, where that particular service could be found. It's defined through software defined network so that your external clients can access that particular service. So even with that particular thing, internally they are mapped to a service. So if a particular service goes off from a one node and starts running on another node, all of that is transparent, or all of that is immaterial for the external routing service, because the routing service will be mapped to a new instance of that particular container running somewhere because they are mapped to the same service. So that kind of shields you from any infrastructure related challenges, killing some of the nodes. Still your service availability is there, and there are no changes done on your client side for accessing that service. The next thing is about the collaboration between various teams, whether it's a dev, QA, ops, all of these things. You require that they own their own instances of their runtimes, and that's where you can club them together, saying that these are dev environments, these is QA environments, and all this. So you can have team ownership, you can independently deploy instances, you can have continuous integration and continuous delivery. We say that, hey, this is now running on dev, I'm satisfied, I'm pushing it to a QA environment, and from QA I'm pushing it to prod. All of this becomes very easy. Your CI/CD workflow is very much simplified there. Now OpenShift adds its own set of tools, whether it's integration with GitHub or GitLab, Bitbucket, or you provide the registry where the stuff is are stored and you can map to. It provides you with webhook API so that any code changes that will automatically trigger a build and all those things. It provides integration with technologies like Jenkins, which will help you create your own CI/CD pipelines. Now, in a monolithic, you have a release plan, then you have multiple teams. They need to be dev teams, they need to be in coordination, they need to reach all that logical end, or some of the team have to wait till other things come in, and then they do integration, and then they will be pushing it out to QA, and then it releases. It's a very inefficient way to do it. And in microservices, each one can go with own plan because they will be handling different level of complexity, which will require have a different number of developers allocated to them, so their life cycle will be different, and that's where they have their own dev, QA, and prod life cycle, and they are implemented differently. So there's no single bottleneck or an efficient execution plan over there. Now, talking about application density scaling up and down, because this is delegated to Kubernetes, which is included in OpenShift, you are really not doing much over here in terms of your delegating all the things to your platform as a service, which is OpenShift. You can add and scale, you can set policies how much it can be scaled and all of these. Now you can also have, we provide cloud forms, which is a cloud management and monitoring technology. We have embedded some part of that technology within OpenShift, through which you can have great number of visibility about what containers are running, what is their compute capacity utilization, like how much CPU, memory, and storage they have been utilizing. You can see all the graphical things at the level of pod, containers, and nodes. Now, apart from that, there might be certain services you may want to club together and compose them. So using something integration technology like JBoss Fuse will help you, saying that, hey, service A and service B need to be together, one need to be called after the other, and so on and so forth. I do activity A in service A, and activity 2 in service B, and activity 3 in service C, and they need to be called sequentially, or there needs to be some transformation between B and C. All of these things, composition of routing and all those things, can be done by using JBoss Fuse, which provides you ability to define multiple endpoints using 160 plus camel endpoint options, or creating using certain patterns, or you can use asynchronous broker network messaging technology like JBoss AMQ, or you can have an event-driven architecture and define your services and your backend tools in this particular manner. Now, microservices and enterprise applications, you primarily are leveraging benefits of both infrastructure as a service and platform as a service. So all automated deployment and testing, ability to discover your service on the go, doing load balancing, throttling, API gateway management, all of these are provided by OpenShift. And now, if you look at how Red Hat brings it all together, all the cloud technologies, we have cloud forms for managing heterogeneous cloud environment if you have hybrid cloud. For the key component within Red Hat for infrastructure are Red Hat Enterprise Linux, virtualization technology, and OpenStack platform. On top of that, we provide container technology by core container technology being supported in Red Hat Enterprise Linux and Red Hat Enterprise Linux Atomic Host. And then we provide microservices by providing you all the middleware technologies that we have to support those microservices architecture. We provide you DevOps implementation guidelines and consulting help, and all of this comes together by using effectively OpenShift, and on top of that Red Hat Consulting. So all of these are brought to you together by Red Hat as a technology provider. I hope this was useful, and thank you.